Hello, children of the Greater Edmonds School District area and surrounding boroughs, neighborhoods, cities, towns. Okay, moving on. This is Physics Lesson 1. Congratulations. You get to hear from me, Aaron, and Eva about physics. Our first lesson will be forces in motion, and it'll be in two parts. Right now, we're going to cover forces, and then we'll also upload a motion video a couple seconds after that. So,
Okay, so let's talk about Sir Isaac Newton. So he lived in England in England in the 1600s and was one of the very first physicists, and also just a really good mathematician. A lot of the reasons why we know how objects move is because of him. And he's also the man behind the famous apple falling story, as you can see on the screen. When he was sitting underneath an apple tree, an apple fell, and he started wondering the reasons for why it fell. He started asking questions like, why did it fall straight down rather than side to side? And he then came to the conclusion of gravity.
and now you may be wondering, what is gravity? The complicated answer is that we still don't really know, but in the simplest terms, it's the thing that keeps you on the ground, the invisible force that makes sure you don't fly off into space and die because there's no oxygen. So, yeah. All right. But what is it really? It's a force. That's what it is. And a force is just a push or a pull in the simplest terms. The unit used to measure force is named the Newton after Sir Isaac Newton. But between any two objects relating force back to gravity, regardless of their mass, there's a gravitational pull. However, larger objects like Earth and other planets in our solar system are large, and thus they exert a much stronger gravitational pull. However, the pull is not affected by the mass of the other object, and this is the reason why, if you were to say drop a pumpkin and an egg at the same time, two things that weigh completely different amounts and have different masses, they would still hit the ground at the same time. This is because the gravity on Earth and other bodies is constant, and for Earth that value is 9.81 meters per second squared. So the acceleration of falling objects is 9.81 meters per second squared. Other planets with different gravitational pulls have different constants. For instance, the gravitational acceleration or pull on Mars is 3.71 meters per second squared.
Okay. So gravity isn't the only force. So some other forces include normal force, and you can think of it as kind of working opposite of gravity. So they work together to keep standing. So gravity pulls you down while normal force pushes you back up. So normal force is basically the reason that you don't get squished into the ground or like pulled into it by gravity.
Well said. Now we are on to friction force. We've all heard of it, but do we actually know what it is? Yes. Friction force is a force exerted by a surface as the object moves across it in the opposite direction. This is actually the reason cars move, because the frictional force of the road interacts with the tire and helps it spin really fast. Yeah. Frictional force is actually closely tied to normal force, which is why heavier objects are much more difficult to move, because the relationship means that normal force is higher on heavier objects, and thus the friction force is higher.
Okay, and there's going to be other forces. There are other forces that we're not going to get into, but they also influence the way objects move, such as air resistance force, tension force, spring force, and also something called electromagnetic force. So yeah, these are all forces that just influence the way objects move, and we'll get into the motion of them in the next video.